Hello, welcome to another session. I'm Gareth and I spend time each week basically building stuff. Today we're going to spend some time on RL and learning more about reinforcement learning. We're going to walk through an example and try and get to an endpoint where we have some reinforcement learning implemented. I'm going to jump over to this machine. I'll be back in a sec. All right, we are back over at my computer. We're gonna, I guess just think about this from the start, where we're gonna play this game where we try and track this mic, where we, ChatGPT is, I'm using this new browser for ChatGPT. Welcome back. We are going to play a game to help learn about reinforcement learning. First, we're going to basically do this like cookie trait thing for donut or cookie, and we're just going to basically build this reward loop. So, okay. So first, we're going to import random, import time. Our actions are going to be cookie or donut. Then we have this thing called Q, which will track these estimated values. You can probably think of this as like quality is probably the simplest way. And it's going to produce a score. So I'm going to say alpha is going to be the learning rate, epsilon is the exploration, and then we'll do 30 rounds. Let's make this fun. Cookie or cookie or donut. Pick an emoji. And then the agent's basically just gonna learn over time. Okay, so then we're gonna like random flips, which is better. So do best for random choice actions. Then we'll do best I like this like new stuff from Google. We'll do rounds plus one if, oops, why do I always do this? If random dot random best is going to be the donut if best equals okay. Then I'm going to do like a if random Yes, we're going to accept this. Then we're going to do a reward. I'm not sure why qget doesn't work. To figure that out. Then we'll do the reward. One if action best else. We'll give it a score of -1. That'll be the reward, and then Q action is going to get updated with the alpha times the reward minus action. Print. Oh, anyway, all these things are not in the loop. Update the learning rate. And then if Q equals action 0, Q actions 0, down actions 1, Q actions 1, and then we'll give it a time to sleep, and after it's been through these rounds, print game over. And then let's look at the print. We actually just want the Q score. All right, let's see if we'll get this to run. Doesn't like this. Print reward. Maybe I need. Oh, here we go. Just gonna like randomly select and do this 30 times. And then we'll get this like final Q score value. So let's see. So this just means like people got, there was more value in clicking the, is basically saying that like cookie usually pays off and the donut usually hurts based on these two scores. All right, let's go on and do another example now. Now that we spent a little bit of time on this, I realize this is like super small to read. So we just went through this like game of donut versus cookie. Let's do another one. So now let's expand on this and add in some states. For morning, afternoon, and night. And basically we're just adding like an extra state in here, so it's going to look something similar to what we had before. Let me so here we have like the possible actions, the possible states, and then we're just creating Q values for each individual state. We'll do 50 rounds this time. We'll see how this runs. And see how it's like updating at each time, so there's like some rule changes in here. Let's see if it flips the rule as to like when the best time to have a donut, to have a cookie versus donut is. So like this is what the output is. And it's basically saying that the best time to have a cookie, the agents learn that picking a cookie is better in the morning, but having a, and then in the afternoon, it seems like they're both slightly negative. And then in the night, the donut is clearly the best time to have a donut. I think I agree with that. All right, next we're going to do something maybe more complex. So we have this game, but right now what it's doing is we have sort of like this instant reward. So if you have a donut, and you have a cookie here, they both basically, and then we just introduce like morning, afternoon, and night. We're going to get these rewards basically for like each state. So this is going to like cross, right? So it could be like here, this could go here. There's like all of these like interweaved states that could happen between these two, and then this also does the same thing, right? Where it gets this reward. So this is one state which is like just like instant, you sort of get this instant reward. The next thing we want to do is like do some like longer term where you might want to like combine these gains. So it's like, you don't just want like one reward here, you want like time to play a factor. So it's like not, maybe a better way to describe this would be just like about like a road trip. So let's assume like you're going to San Francisco. From LA. And like, yeah, just right now we're just looking at like one stop. But what we're saying is, and then like that will equal some reward. If we're going to SF from LA, and let's say we have like one stop, but this stop might be like not the best, but leads us to Carmel, then it gives us some better result at the end. It gives us like a higher reward, if that makes sense. Into LA. Sorry, I'm trying to figure out how to explain this. You get a reward and you, I don't know, you stop at Chick-fil-A. I think that's how you spell Chick-fil-A. This one you do 2 stops. You do 1 stop at McDonald's. Not the best, but then this leads us to Carmel. Well, that makes sense. So we're going to do an example here of this, of some code that will represent a little bit like this road trip example. So, maybe I'll just map these out too, because it's probably easier. So let's do this. Let's do some RL mapping. So table, these various states. So there's going to be state, action. Whoa. There's light tabs. This is gamma. And then we'll have this Q value again, which is sort of like how good it is to pick. Alright, so our state is basically like where you are. Where to stop to eat, how happy we are with that decision, and then also we want next day, like the next city on the trip, and then our gamma is going to be how much you value future destination. Okay, so we're going to do something similar in our next example with this code. So let's go back here and some more code in. So this, let me walk you through this. So there's like San Francisco, Carmel, and LA. There's McDonald's and Chick-fil-A. There's these environments. Transitions is like San Francisco, Carmel, Carmel, LA, LA, San Francisco. Then there's going to be like some reward steps. So like you get base food happiness. So there's like this reward step here. And then there's like the trip completion is 5, but you get like a bonus for going to LA and a bonus for going to Chick-fil-A. And then we've added some randomness in here. And then there's like this training loop that we're going to go through. All right, let's run this. So this is like producing some results. How many steps did I put in this? 50 steps. Okay, so it's going to run, and then we get these results. And these Q values are super interesting. Okay, so it seems like it's like favored McDonald's more from what I can see in this step. So you can see like this stop is typically I say this just because I can like looking at the data, there's like only Chick-fil-A is like 3 times in this list, so we know we need to improve it. Let's create another code block and lock. Okay, at least I see some more Chick-fil-A in here right now. Okay, this is going to go a little long where I put 60 in. Okay. So let's look at this. How do I get to the end? Okay, so high numbers here are sort of the expected long-term reward. We see like higher values basically in the Carmel and LA if we stop at McDonald's or at Chick-fil-A on this journey, compared to just going to San Francisco. So it like has produced some some better things. It's basically just learned that there's like McDonald's leaded to the highest expected long-term reward across the road trip. So if we were going on a road trip, we would probably do that. All right, let's skip to another example. All right, let's keep going. Do we deploy a service?
terminate it. Not sure why it doesn't work. Let's go get one of these. Cool. All right. Let's go ahead and run. This. And pray that we don't run into CUDA issues. Let's see. So we're using OpenChat as the base model. We're then have this reward function that's based on helpfulness, safety, and truthfulness. And we're going to use this to do like reward functions through this model. So we have the Stanford NLP data. We can use PPO. Then we're going to go through this loop basically where we batch and get some prompts, have a tokenizer. We have a reward function that's going to pack the responses, and then we're going to save this. Hopefully it takes about 30 minutes. We'll see. Pip install. Let's see if it needs it restarting or not. Sure you can see it. Just going to get the model. Doesn't like this. This doesn't need the model name. All right. PPO epochs. PPO trainer. It's so weird. I don't know why they mess with the PPO trainer. This just seems so weird to me. Why they like messed with the names. So they just like moved everything to the trainer basically. Is that right? Doesn't even want to tokenize it. Doesn't even want any values. Device as you see. Let me try and find out what version of TRL this is running. What version is this? I mean, it's asking me about... Come on. Where's the docs on this? This was PPO. Okay, so it's just... So they don't use GRPO trainer. Let's try this. So important torch. How'd this lower the this works? I guess they just like have been trying to what is going on here? Okay, where is your TRL? it's weird how it just, when you, that it's not picking up the... Nope. Max. I'm just going to take these out. What's in the docs? Yeah, it doesn't even want any of these variables. Let's try again. I need to spend so much time just trying to get this thing to work. Damn, I ran the wrong one. This is definitely going to fail. Does it have an output directory even? So wild. Oh god, I'm gonna run out of memory on the GPU. I'm gonna have to flare it, I'm guessing. Not entirely sure what it's doing right now. While it does that, I'm gonna stop it. And make sure I do this to clear. No, I should run it. All right. Let's let this cook. Well, this is going to take longer than I think. This is going to take too long. Yeah, it's only through 2, so let's change this up. Let's find the GRPO. Okay, so I probably want to just like change some of these settings. Let's try run another one. Where are you? It's not going to accept any of these things. Let's try this again. I don't know why they make their args so difficult. This is called args. Generation size 4 must be finally, we got something running. Okay. I just know this is going to work, so I'm going to keep on interrupt it, go back here and get the this thing. And then this is going to do this reward for help, safety, and truthfulness. This is all logs. Let's hope it runs. Come on. It's done 2 of 50. Like, this stream is going for a long time. gotta get this faster. It's just taking too long. Would you stop? See if this runs now any faster. I don't know why I keep seeing device sets that use CPU. And this is doing this like score and labeling with these pipelines. So one is like a help as sentiment analysis for help. The other one is for text classification for toxicity, and then this is some fake news thing that does truthfulness. I have no idea why this is so slow. Okay, let's move these onto GPU and see if that's what's causing this to slow down. It's like instantly faster. It's got a train loss of 0. So funny. This is what I wanted to get to though. Now I gotta clean this up. Okay, so let's do do some normalization of this spread. Multi-reward. And then alright, let's try and run this. I think every 10 steps it should show the step in the training loss. There's a couple of reasons why this might continue to be 0. One is the learning rate is too low. There's too few steps. There's some type mismatch. Looks like it's 0. It's minus. Let's see what happens after this. Let's see when it gets to step 30. Let's wait for this to run. So this is a good idea. This is gonna like test these things. Oh, that's weird. Oops. See if this changes things. Okay, let's change this run and put this in here. Make sure the multi-reward is here. Okay, let's clear the GPU and run this again. And just pray that loss is not 0. Please. Yeah. Okay, so I can boost. Okay, we're gonna wait for this to run. There is so much tuning to do with these models. This is only a small model. I mean, what, I've spent like almost an hour on this, maybe more. All right, we're at 100. Let's run this generation. Of course, it doesn't work. What did I save it as? Unrecognized model should have model key in config. Okay, let's see if we can do this. Okay. Alright, now we should get the two combined against each other. And I'll probably call it that. Okay, so I like how it's got like some positivity in here. You can also add some so our tuned rewards here are higher than the base. So this is showing some improvement. We could probably just change the learning rate and some other stuff on this. Right, let me jump to my other machine. All right, thanks for bearing with me on this one. This was pretty long. When you get into some of the tools within PyTorch that like have changed a lot, that TTL library took a long time. Anyway, today we learned I learned some more about doing some reinforcement learning with sort of GRPO and using that as a tool. We started out doing some like very basic training with donuts and cookies, and then we then we got a little bit more advanced and did this drive from San Francisco to LA, and then made like some decisions, which was like multi-step. Then we took that like one step further and looked at a model that had helpfulness, trustworthiness, and toxicity, and use those like three models to produce some like reward score on top of the model that we trained and put together, and we got some good results around like the comparison. We ran into some tedious issues, I would say, with the GPU, but yeah, it's interesting like how these models come together in some way. I think that in post training, like having something that has these reward functions is like very helpful. And yeah, it was interesting. I think there's like a lot of opportunity for some of just like smaller models that do some of this like very helpful sanity checks that seem like super useful. So yeah, if you spent any time today, I appreciate it.